The last group we're going to work with are acids. So remember, we have three groups: ionic compounds, we have covalent compounds, also called molecular, and then we have acids. Now remember, acids are a type of ionic compound. But remember, to identify which of the three groups to work with, look at the first element. If the first element is a metal, then I'm dealing with ionic. My focus is on charges, and I have to make sure I bring them in together in my cation and anion, or my metal and nonmetal, together in the correct ratio so they add up to, or so the charges, add up to 0. Then we have the covalent, and again, those are identified because the first element is a nonmetal. And this is the only time you get to use your prefixes. But last group we deal with are acids. Now acids are easy to recognize because they're the only ones that start out with hydrogen. There are a couple of exceptions to the rule. There is water, which is called dihydrogen monoxide, and then there's H2O2, which is hydrogen peroxide. Please remember, hydrogen peroxide is the over-the-counter name, but it's also the accepted scientific name. So once we identify starts out with a hydrogen, it's an acid. Then we ask ourselves the next question, and that is there an oxygen present? This is where we have a Y in the road. If there's no oxygen present, like you see our three examples at the bottom there, HBr, HCl, and HCN, you realize then that you always will start out with the prefix hydro. If there's no oxygen, we always start with hydro. We identify the stem, and the first one, that's bromide, because remember, it is a ionic compound, so it's bromide, and I changed the I to ic, so it's hydrobromic, and I throw the word acid at the end of it. But I always start out with hydro. Why? Because there's no oxygen present. That's the only time I start out with hydro. HCl is hydrochloride, changes the ic, so it's hydrochloric acid. Now, the HCN, it is unique because, yeah, it isn't binary to it does have three elements, but cyanide does not have oxygen in it as the key. So it is hydro, and then cyanide changes to cyanic, and I put acid at the end of it. So hydrocyanic acid. That's our first Y in the road. So let's start over. We start out with a hydrogen, we know it's an acid. We ask ourselves the second question, is there an oxygen present? If the answer is no, then we always start with hydro, change the anion from I to ic, and add the word acid in. But what if there is an oxygen present? This is where we talk about a ternary. Ternary just means there's three or more elements present. But when there's an oxygen present, that means we're dealing with one of our polyatomic anions, which I'm testing you on. So if there's an oxygen present, to name the acid, it's only based upon the polyatomic ion. And there's a couple rules to follow. If the ending of my polyatomic ion is an 8, I just change it to ic and then throw the word acid at the end of it. For example, HNO3 starts out with a hydrogen, I know it's an acid. I look at my, is there an oxygen present? Yes, there is. So to name it, I focus on my polyatomic ion, which is NO3 minus, which is nitrate. And nitrate, I change to nitric and throw the word acid at the end of it. So look at this. My hydrogen is a +1, nitrate is a -1, and they come together in a 1-to-1 ratio, and they zero each other out. That's why I only need one hydrogen. Look down, my next one, sulfate's a -2, so I need 2 hydrogens to zero it out. Phosphate's a -3, so I need 3 hydrogens to zero it out. So it is a type of ionic compound, but the hydrogen is acting as my cation in this situation. Second one, HSO4. Again, starts out with hydrogen, it's an acid, an oxygen present, so name it is based upon sulfate. Now be careful about sulfate, sulfur, and phosphorus. Sulfur and phosphorus, they do this. Their full names come back into play. So sulfate is sulfuric acid, and phosphate is phosphoric acid. Their full names do come back into play. Now when we ran into 8, we also ran into ite. Remember, we take an oxygen away, we have ite. Well, what does ite do? Well, if we have ite, it changes to us. So 8 changes to ic, and ite changes to us. So again, it starts out with a hydrogen. We know it's an acid, and oxygen is present. To name it, we focus on the polyatomic ion in this situation, which is NO2. NO3 is nitrate, so NO2 is nitrite, so it's nitrous acid. Again, SO4 is sulfate, SO3 is sulfite. Remember, the full name comes back into play, sulfurous. PO4 is phosphate, so PO3 is phosphite, and it's phosphorus. Now be careful with this one, because remember, phosphorus acid is OUS, phosphorus as an element is ORUS. So the phonics can throw you out. Be careful about that. Now, that's going from formula to name. What about going from name to formula? Well, once you see the word acid, you know it starts out with a hydrogen. That's a gimme. Now you look for the word prefix hydro. There's no hydro here. That means it's one of my polyatomic ions with an oxygen present. So cyanic changes back to cyanate. Cyanate is OCN minus. Now +1, -1 add up to 0, so it's an HOCN 1-to-1 ratio. Then my next example, I cut out some stuff in between there. The next example, acid, starts out with a hydrogen. Now it's a prefix hydro. What does that mean? It means no oxygen is present. It means you're dealing with one of your individual anions. Well, sulfic changes back to sulfide. It's in the same column as oxide, oxygen and sulfur, so it's just sulfur, but we have a -2 charge. Now I have a +1 and a -2. How many hydrogens do I need? I need 2. So it's H2S.